Ladies and gentlemen, good morning. Today, I would like to present to you some of the recent progress on applications of Minfield type game theory, that we call MFTG, in the context of dynamic routing games for road traffic as well as for computer routing games. So what is new here? So the new thing is the combination of dust measurement together with the traffic measurement. We put those two things together and then use MFTG, meaningful type game theory, to address the traffic behavior and healthcare issues. So this is really a first kind of study in this nature, and that's why I felt like it's very important to disseminate and share with our peers. So first thing first, what is game theory? In the baseline, game theory means interactions between several entities, so two or more entities. And entities, by entities we mean people, it could be animals, it could be machines, it could be genes, and interactions between several combinations of these things. In terms of modeling, the main idea is to say that those decision makers, those entities, have some influential parameters. Those who have influence, we call them decision makers. And a decision maker has an influence in the outcome of the game. So they have to make a decision, so there should be a certain set, known or not, that we call decision set. So, and then when all of them make a decision, then and the influences of uncertainties and so on leads to an outcome, right? And that could be sequential or simultaneous. Simultaneous doesn't mean that the decisions are taken at the same time, but in terms of information, making a decision without knowing the decision of the others. Now, what is Minfield type game theory? So what Minfield type game theory does is to extend this framework to consider not only state action pairs in the outcome, but also the distribution of state and or actions in the outcome profile. So the outcome could be a pair function, utility function, and so on. And classically, generally, the expected utility, the expected payoff, the expected performance have been widely studied. However, we should go beyond the expected value in many examples. Variance plays an important role, quantiles, and higher moment. So if you are interested not just on the expected value, which in many examples is just a trivial value, but also on other parameters like variability of the outcome itself, the risk measures, then you need to extend in general some of those measures. And that's what Minfield type game theory does. So it's include not only the expected payoff but also higher moment of those payoff, and also of course in the other dynamics that are involved could be the state and so on. So now why is Minfield type game theory needed in this routing with dash measurement fact? Well, for the same reason. In the road traffic, in the traffic measurement that we have been conducting, of course, environment matters. Of course, if you are a person, a motorbike or in a car or a pedestrian, then you are at some point interested in how dusty is the road as well. Not just there is a congestion level, but I am not that protected. I live in a place where less infrastructure or rural built, so it could be dusty, and people understand what I mean by dusty. And in that case, you are interested not only in the portion of the traffic, in the portion of the congestion level, but also in the dash measurement. And this is what we have been doing the last 2 years. We have measured the dust over several portions over across several cities, and we have been sharing in MFTG with you. And now we put them on place, we put them over a graph, and then we got a routing game. By the way, what's a routing game? Well, a game, an interaction between source and destination pairs over multiple hops, steps that we could say that could be seen as a graph or as a network, right? So it's a particular network game. But however, it goes beyond the congestion games, it goes beyond road traffic games, it goes beyond computer network traffic games. And now the new thing is we combine this routing game with dash measurement. So it becomes multi-objective. Of course, the routing game is already multi-objectives because with your source and destination, you have several people. But you have another objective, additional objective, which is the intensity of the dash across the roads and around the roads. And that's evolved over time. So that dynamics will be coupled, and it influences the decisions for those who unfortunately have health issues and have to follow recommendations. So put all this together, we think that meaningful type game theory applied to this routing game with dash measurement is very, very important, and it start getting a big impact, a big societal impact. So this comes into our picture, our agenda, which says MFTG for social impact. Thanks for watching, and see you soon on MFTG.